This is Biomaterials, Lecture 13, Video 4. Let's go over the solution to this problem. The correct answer is A. Cadmium has a standard electrode potential of negative 0.403 and a molar concentration of 0.5 moles per liter. Nickel has a standard electrode potential of negative 0.250 and a molar concentration of 10 to the negative 3 moles per liter. The nickel and cadmium ions both have a charge of positive 2, so 2 electrons are participating in the half-cell reactions, so N is equal to 2. If we plug in all these values into the Nernst equation, what results is a voltage difference of negative 0.073. Notice that this is a negative value, which indicates that the initial assumption that nickel is oxidized and cadmium is reduced is incorrect. If we assume that cadmium is oxidized and nickel is reduced, we will obtain a positive value for delta V, which means that this is what truly occurs when the two half cells form a galvanic couple. So we have discussed standard electromotive force series, and you have experience using the Nernst equation, which can be applied to galvanic couples under non-standard conditions, like different molar concentrations of solutions and non-ambient temperatures. However, there is an even more practical series that can be used relatively quickly and does not require calculations. This is called the galvanic series. The galvanic series represents the relative reactivity of a number of metals and commercial alloys in seawater. The galvanic series is shown here. Metals and alloys that are near the top of the series are increasingly inert or cathodic, while metals and alloys near the bottom of the list are increasingly active or anodic. For example, silver is located above tin in the galvanic series. If silver is connected to tin and the two metals are immersed in seawater, then tin will corrode and silver will not. If tin is connected to lead and immersed in seawater, then the lead will corrode and the tin will not. This is because tin lies above lead in the galvanic series. Here is the galvanic series next to the standard electromotive force series. Note the similarities between the two, but also note that the data on the standard electromotive force series were taken in a very specific condition and does not include alloys. The galvanic series has a number of advantages because it is a quick reference that does not require any calculations, includes alloys, and does not have to be at a standard temperature of 25 degrees Celsius. You can simply look at the galvanic series and determine which metal will corrode if two different metals are connected together in seawater. Let's apply what we've learned. Imagine that a copper fitting is used as a coupling for two steel pipes that are used for transporting seawater. Based on the galvanic series, please select the correct answer from the options shown here. Please click on the link below to complete this in-lecture question and receive credit for your work. This is an open book, open note assignment. You may take as much time as you need, but the important things to remember in these in-lecture assignments are that you do not ever hit the back button on the form and you complete the questions before starting Lecture 13, Video 5. We trust you to follow the honor code. We will go over the solutions to this problem in Lecture 13, Video 5, which is also linked below.